welcome to my DNA sequence program. This is in Java, and it is a simple program to show how we can use different methods with strings to, in this case, search for certain characters that we want to search for. This can be used in a lot of different situations, but a DNA looking for proteins and certain sequences of DNA is a nice example that we can use to show some of this functionality. So I made this with starting with three variables, just strings of DNA here as samples that we can search through. The first thing I did after creating a few just sample strings of DNA is creating a new variable, just DNA, rather than numbering it. This will be a general DNA variable that we can use as a kind of surrogate when we're applying different methods to our strings. A first example of doing that would be to apply the length function to whatever DNA sample we want to set this to. So we're going to set it to 3 and see if it works. And so when I run it, I get 15. So 15, yeah, that's the length of the number of characters in sequence DNA 3. So we can make sure that it works by changing that to 2, for example, and running it again. And here we get 13, which looks right. That's less than DNA 3, so that's working. I'll switch that back. And now we can move on to what our main goal is, to look for certain sequences. So a little bit of biology terminology. A sequence of 3 genetic base pairs is a codon, and these are the building blocks for a codon codes for an amino acid, and amino acids can be strung together to make proteins. So in order for there to be a protein existing, there has to be a specific codon, which is known as a start codon, and it's ATG. That's the sequence for a start. And so a protein needs to contain this and also a stop codon, which is TGA, in order for a protein to exist. So let's do the index of method, call that on our DNA variable, which is still set to DNA 3 here, to see if we have a start codon, ATG, or a stop, TGA. And we're going to run this again, and it'll find out where those are. And if it doesn't have it, this index of method will return a -1 to just say there is no index. Otherwise, the index would be 0 through n number of characters. And here, in fact, it returned a 6 and a 12. So another point about the index of method is that it's going to return the index of the beginning of the sequence that we're searching for. So it should be returning the index of the A. So let's check DNA 3, 0, 1, 2, 3, 4, 5, 6. And there's our A. So that's working correctly. And TGA is telling us that it's 12. Well, if we know that there's 15 characters in the sequence, we can count back 3 to 12. So 14, 13, 12, and there's our T of TGA. So both of these searches, these index of methods, are correctly finding the sequences that we're looking for. So that's great. And that by itself can be pretty useful. And now in this context, though, we can actually do a little bit more with this concept of proteins. So what I did was assume that a protein is a sequence of base pairs that not only contains this start ATG and stop TGA, but also as a whole is divisible by 3, because 3 is necessary for the amino acids. And we're going to say that if it cleanly divides by 3, it's a protein. Okay, and in order to do that, I created a couple if statements here, to conditionals to determine that. The first one is a conditional first to see whether there is a start and a stop. okay? So we're kind of using a double negative here. We're saying that if the index of ATG is not -1, that means that that index exists. There is an index for it, okay? And if there is also an index for TGA, the stop, same logic there, then if that's true, mission accomplished on those first two conditions, and we'll move on to the next test, which is to see whether the entire sequence is divisible by 3. So here we're going to take the index of TGA minus the index of ATG and see if that's divisible by 3. Now there's a few things going on here that kind of work out conveniently for us to make this fairly simple if statement work. Of course, when we're finding the index of TGA, it's cutting off the last 3 characters because it's, as we saw here, returning the index of 12. So it's cutting off the last 2 characters. And it's including the ATG because it's counting the first A as part of this sequence. But since these start and stop codons are both divisible by 3, it just works out that the result is also divisible by 3. If that wasn't the case, we would have to adjust this if statement a little bit, but because it is the case, fortunately we can do it fairly simply. So moving on from that, we're gonna, if those are all true, then we've got a protein, and we're gonna print out that the conditions 1, 2, and 3 are satisfied. Now, another note here, we're lumping all 3 of these conditions together, and if we wanted our output to be a little bit more specific, we could break these if statements up so that we print a message if any one of these fails for more specific feedback. But in this case, we want to know yes or no, are all those conditions met? So that's what we're doing here. And then if they are met, further, we want to know, well, what is that protein then? We don't want to manually look for it. We want the program to just cut it out for us and show it to us. So here we're going to declare a new string variable called protein. And using the substring method on this string, that's what it's going to do. It's going to find the substring of this sequence that we can search for by referencing first the beginning of the sequence that we're looking for. So that's going to be this ATG, which is the start, and then it's going to be the end, which is the TGA, the stop codon. Now, we have to adjust this a little bit because the substring method, the second defined index here is exclusive, whereas the first one is inclusive. So it's going to automatically include the ATG because it's going to start with the A, but it's not going to include any of the T, G, or A. So we want to add 3 to this index to include those 3 characters in addition to what it normally is including to catch both the start and this stop, okay? And so that's going to return our, once we print it here, it's going to print our protein. So here we have a string just saying here the protein is, and we're going to display the variable protein that we defined here. So, and the last part then is in the case where it doesn't meet all those conditions, this is the else to follow the if statements. If those things aren't true, then it's not a protein, right? Either it doesn't have a start or it doesn't have a stop, or it's not divisible by 3, and we're going to say no protein. All right, so with all that said, let's run it and see if it works. Okay, and we're still testing DNA 3 because that's what we have DNA set to. And here we go. Condition 1, 2, and 3 are satisfied. That's great. And here's our protein, and there's the ATG start, there's the TGA stop. And so this is characters 6 through 15, or 7, since the index is 6, through 15 of our sequence. And that's great. We've just extracted the protein from this string, which could have been a lot longer and a lot less comprehensible. So it's pretty useful there. Now let's just see if this is working by setting the DNA to one of our other sequences. We'll do number 2. and see if that's a protein. And again, here now, looks like we have both a start and a stop. Otherwise, we would get a -1 here as the return of the index. But unfortunately, it's not a protein. So we can see, since it has a start and a stop, then the problem must be that it's not divisible by 3. And that's true. It's got 13 characters, as we used our first method there, the length for. So we know right there that it's not divisible by 3, not a protein. So it's looks like that's working too. And let's just try 1 here since we created it. And return is that 1 is also a length of 15. It also has a start here, starting at index 0, so our first character. And we can see, yes, ATG is the first 3 base pairs there. And it's a protein, and it printed it out for us. So it's working for all 3 of our samples. Thank you very much.